show you another example on evaluating a definite integral. So far we already covered two examples. Guys, I'm trying to show you these different types of examples, but the basic idea is still going to be the same. At the end, we're going to use the fundamental theorem of calculus. Guys, we did not really prove that theorem, but we wrote that theorem, and it's not too difficult to actually use that theorem to evaluate the definite integral. So let us look at this particular integral right here. Again, looking at this piece right here, the quotient function, we cannot directly come up with the antiderivative of this function. So if we cannot do that, then either we have to think about the shortcut method, which we have already covered, but this does not really qualify for the shortcut method. So one has to use the method of substitution. In order to solve this, guys, let us first rewrite this. I mean, it's up to you whether you want to do that or not, but I'm going to rewrite this. So I'm going to rewrite this as, well, 2x stays upstairs, and downstairs I realize the fact that there is raised to the power 1, the denominator is raised to the power 1. So if I bring it upstairs, it's going to look like x plus 2 to the power negative 1, okay? So from here, what I can see is that to start the substitution, obviously we like to start with a quantity or a function that has an exponent here. So obviously this has an exponent. So I would like to start with substituting this as u, okay? So let us start with that step. The first step being setting u equals to x plus 2, okay? And then the second step for the substitution method is to evaluate the derivative. Let us do du over dx. In this case, it is just simply 1, which implies that dx just equals to du, which actually is a good thing. That makes life easier for us. So we just box those two things that we need for step number 3 to work. But there's one more thing we have to do before we go to step number 3. And guys, if you remember from my last video, is that we have we're changing the variable from x to a u. So that means the limits, the lower and the upper limit will also change. So that means we have to calculate the lower limit, the new lower limit. So we have to substitute -1 for x. So if I do that, -1 plus 2 is going to be just +1. And we also have to evaluate the new upper limit, which is this u upper. And then for that, you have to substitute x equal to 1. So 1 plus 2 is 3. That is my new lower limit and the upper limit. So it's 1, 2, 3. Then we have to go back and start substituting values. Guys, 2x, well, I got to leave it like that for now and hope that and expect that this will cross out somehow. And let's see what happens here. Guys, there's an x plus 2 to the power -1. So, I mean, you can write it like this or that. So let us use this way of writing things, okay? Guys, it's up to you. You can also use the first one, which means like this one. So it's going to be x plus 2 to the power -2. X plus 2 is just u, so I can just write u to the power -1, right? I'm substituting back. And then dx is just simply du, okay? Although we were hoping that this 2x crosses out, but it did not cross out. And as I told you earlier in my other videos as well, that there are times when it may not cross out. So in that case, you don't have to freak out. We just go back to our step 1 and see if there's a way for us to get this x or this variable in terms of u. Guys, as long as this is a linear function, it's easy to actually convert it or solve for that particular variable in terms of the other variable. So this is a linear function. From this, we can solve this for x. And if I solve this for x, what do I get? I get x equals to u minus 2. So I can replace this x with u minus 2 because everything now is in terms of u, and we want everything in terms of u as well. So we don't really like that x here, but there's a way for us to get that x in terms of u. So we go back to step number 1, solve for x in terms of u, and we can solve this expression in terms of u. So u minus 2. So let's go back and replace this x with u minus 2, and now everything is in terms of u, which is what we wanted. Of course, there's a u to the power -1 and du. Okay? Guys, this is the expression now that we need to simplify and evaluate the integral for. But it was almost impossible to find the integral for this expression right away, just looking at it. But using the substitution method, we are able to transform it into something simpler and something that we can evaluate the integral for, okay? So let's take it up here. So what we are going to do is, again, there's few ways that people like to do it. I'm going to take out that 2 right away. So I'll take out that 2 outside, and then I have integral. Guys, some people like to keep that 2 all along, but I like to take it already outside, and then I distribute it back at the end. And then there's 1 to 3. It helps me so that I don't have to worry about writing 2 all over again all the time. And then, guys, once I take this outside, I'm going to first write u to the power -1, and then I'm just rearranging things, and then u minus 2, and then there's of course a du. Now let us simplify further. Simplifying further, I leave that 2 outside, and then there I have 1 to 3, lower limit 1, upper limit 3, and let us, what do we need to do here with that u to the power -1? We just need to simplify that piece. That means we just have to distribute it. So if I distribute this, so u to the power -1 times u, so there's a power 1 here, so when you multiply them, the powers have to be added. So it's going to be u to the power 0, -1 plus 1 is 0, then the second term is -2 u to the power -1. I'm going to put that in parentheses as well. It's 2 terms, and then a du, right? Guys, but u to the power 0, any quantity raised to the power 0 is what? 1. So I'm going to write 1 here instead of u to the power 0. Okay. Now let's move on. So we have 2, and then integral. So we are going to break it down into 2 pieces, or I expect you to kind of do that on your own. So what we have to do now is we just have to find the antiderivative of these 2 and just write them down, and then draw that vertical line and write the upper limit and the lower limit. So let us start by writing the antiderivative of 1. Guys, the antiderivative of 1 with respect to du is simply u. That is also one of the fundamental rules that we have already talked about, how to calculate the integral of a constant. It is just the constant times x if you are integrating with respect to x, but here it's with respect to du, so we got to have a u here. Then minus, then there's a 2 here, we just don't do anything with that 2 yet. And the integral of an inverse function, we know is what? Is ln of ln of u here, and then that's it, we are done. And then we just have to specify the limits. The limits, upper limit is the upper limit is 3, and the lower limit is 1. Of course, we have to close the curly brackets. Okay. Moving on, guys, there's a 2 outside. Then we just have to use, now we have to use the fundamental theorem of calculus, which simply says that you just have to substitute the upper limit and the lower limit for the variables here. So it's 3 minus 2 ln of 3. Okay. I am going to put this in parentheses as well. Any binomial we like to put it in, we should put it in parentheses. Then minus, this is from the fundamental theorem of calculus, then another parentheses, and keep in mind we still have to close the curly brackets. Guys, whenever you start anything, bracket, or whether it's a curly bracket or a square bracket or a parentheses, we got to close it. If we start it, we got to close it. Okay. And then, I mean, that's also true with when you are simplifying things or doing things on your calculator as well. Here we have 1 for u, so 1 minus 2 times ln of just 1. Okay. Let us simplify this further. So we need some room for this. I'm going to, probably we can do one more step here, and then I'm going to try to find some more room here. Guys, the 2 stays still outside, and then let us simplify this. I'm going to get rid of these brackets, so I'm going to write them as 3 minus 2 ln of 3, and then minus, I'm going to distribute that. Okay, so minus 1, minus times minus is plus 2 ln of 1. Okay, we just distributed the negative, and we just got rid of all the parentheses. Okay, now there is something that we can do. We can combine like terms, but then also the fact is that the ln of 1, we know that ln of 1 is simply 0. So if we can simplify that, then we got to simplify things. So ln of 1 is 0. What does that mean? Ln of 1 is 0. That means 2 times 0 is 0. So this whole term just vanishes. Right? Let me take it up here. I'm just trying to find some space. So far, all the problems that I have done on my videos, I have somehow been able to like condense them on this small board that I'm using here, but this one is like it takes more, it needs more space, so we just made some more space here, but I'm sure we can still figure these steps out. So from here, guys, I'm going to put a star here, and that we're taking it up here. So guys, now we are gonna, I'm just going to rewrite this. This is already 0, so we don't have to worry about that. So I'm rewriting the rest of it. So it's 2 times, and then there's 3. Well, we can simplify this. 3 minus 1 is 2. So I don't have to rewrite that. So I can already say 3 minus 1 is 2. And 2 minus 2 ln of 3. So I think we're almost done. All we need to do now is we just need to distribute that 2. So it's 4 minus 4 ln of 3. And guys, I think that's all. That is the integral. That's the final answer. That's the integral of this given quotient. So there was a lot of steps, but guys, the process, the method was like just starting with the substitution. Since we're changing it to a different variable, we got to get the limits. We got to get a new different limits, which we were able to calculate. Then here we had the x term. It did not just cross out by itself, so we had to go back to step number 1, solve for x in terms of u, and in this case we were able to do that. We substituted back, we distributed this, we used the rules for antiderivatives, then we used the fundamental theorem of calculus. So many things happening, and then we finally evaluated the final answer. Okay, guys, this was a lot of work, but you got to be able to do examples like these. So you have 3 examples on definite integrals, and I think I already did about 10 examples of substitution and other basic rules. So please practice these and then try to do more problems from the textbook.